Welcome back to the channel presenting practice problems for professional actuarial exams. You can find information about me at smarturl.it/Jedi. You can find information about the actuarial program at Illinois State University, which I direct at smarturl.it/actuary. Our program was among the first 9 centers of actuarial excellence as recognized by the Society of Actuaries in the United States, one of the first 9 in the United States, the first one in the state of Illinois. And when the Center of Actuarial Excellence recognition by the Society of Actuaries was started in 2009, we were also among the first 13 programs in the world that received that recognition then. In 2016, we were given the University Award of the Casualty Actuarial Society, one of the first 4 universities in the world to receive it. If you would like to offer help to our actuarial students, please make a tax-deductible donation by going to smarturl.it/help-ISU-actuary. Here's a problem for today. It's for exam MFE. This material actually used to be on exam FM. Now it's on exam MFE. The current price of a non-dividend paying stock is 40, and the continuously compounded risk-free rate of return is 8%. In addition, you are given the following table of call and put option premiums for various exercise prices. At exercise price of 35, the call premium is 613. So of course this call is in the money, and that's why the price is reasonably high. The put price is 0.44. The put is out of the money because the current price of the stock is 40, so it doesn't make sense to sell it for 35 when you can sell it in the market for 40. For exercise price of 40, both options are at the money. 40 is the current stock price. The call premium is 2.78. The put premium is 1.99. And then for exercise price of 45, the call premium is 0.97. And the put premium is 5.08. And of course, selling a stock for 45 when it's trading at 40 is a pretty good deal. But buying a stock for 45 when it's trading at for 40 doesn't make any sense. That's why the call premium is low and the put premium is high. The call gives you the right to buy the stock at the price of 45, which doesn't make sense again because the price in the market is 40. And the put gives you the right to sell the stock at the price of 45, which of course would make sense if the price in the market is 40. You are interested in speculating on volatility in the stock price and are comparing 2 investment strategies. The first is a 40-strike straddle. The second is a strangle, consisting of a 35-strike put and 45-strike call. For what range of stock prices in 3 months does the strangle outperform the straddle? So the straddle consists of buying a 40-strike call and buying a 40-strike put. You buy at the money call and at the money put. The cost of the straddle is 2.78 plus 1.99 of 4.77 at time 0 right now. And that cost accumulated with interest at time 0.25 is 4.77 times e to the 0.02 accumulated at the risk-free rate. So that's 4.87. Of course, continuously compounded risk-free rate. The strangle consists of buying a 35-strike put and a 45-strike call. This costs 0.44 plus 0.97, so 1.41 at time t equal to 0. And the cost grows to 1.41 times e to the 0.02, so the continuously compounded risk-free interest rate, to 1.44 at time t equal to 0.25. So now let us look at the profit of the straddle. For S sub t, the price of the stock at expiration less than 40, the straddle has a profit of 40 minus S sub t minus the cost of it. So if we are under 40, you get a payoff of a put. You don't get the payoff of a call. The call is worthless, minus the cost of the position. While for S sub t, greater than or equal to 40, the straddle has a profit of S sub t minus 40 minus 4.87, so that's S sub t minus 44.87. So these are both formulas in terms of the price at expiration, but pretty straightforward formulas which will allow us comparisons. Notice that it would be extremely simple formulas if it wasn't for the cost of the straddle. We have to account for the cost because we calculated not the payoff but the profit. When you see the word profit, remember that you have to account for the cost of the options and also for the cost of interest. That's why we accumulated the costs of these options at the risk-free rate until the time of the exercise of the option. Now let us consider the profit of the strangle. For S sub t less than 35, the strangle has a profit of, well, the payoff of the put, and the call is out of money then, but payoff of the put, 35 minus S sub t minus 1.44, so 33.56 minus S sub t, while for the price being between 35 and 45, well, the profit is just the cost of the option, so really it's a loss of cost of the position, option position, which is 1.44. So the profit is negative 1.44 or loss of 1.44. And then for S sub t more than 45, the call is now in the money, the put is out of the money. And the profit is the payoff of the call, which is S sub t minus 45, minus the cost of the position, which is 1.44. Of course, that's the cost accumulated with interest until option expiration. So this ends up being S sub t minus 46.44. Now comparing these structures, which they are results of the payoff structures, although we're really calculating profits, but the payoffs, of course, are affected by whether each option is in the money or out of the money and so on. At expiration, we see that if S sub t is less than 35, or if S sub t is greater than or equal to 45, the straddle would outperform the strangle, since 35.13 is more than 33.56, and negative 44.87 is more than negative 46.44. However, between 35 and 45, we can solve for the two boundary points for S sub t, where the strangle would outperform the straddle by considering the inequalities, that negative 1.44 is greater than 35.13 minus S sub t, and negative 1.44 greater than S sub t minus 44.87. So the first inequality gives that S sub t has to be more than 36.57, while the second inequality gives that S sub t has to be less than 43.43. So the result is that the range we are looking for is between 36.57 and 43.43 that we established in this last calculation, and that's answer D. Please remember this is copyrighted material. The exercises that come from the Society of Actuaries, in this case, O Casualty Actuarial Society for some other problems, are copyrighted by these societies, so this one belongs to the Society of Actuaries, but the solution is mine. Good luck in your studies and good luck on the test.